అది ఓకే. Hello students, welcome to IMS GATE Academy. In today's session, I want to start two-port networks. Today and tomorrow you will see the topic of H parameters, Z parameters, the topic of what topics you can do, two-port network we are going to do. In the two-port network, what we are going to discuss? Z parameters, Y parameters, H parameters and transmission parameters. All these four parameters we are going to discuss, and also we are going to do problems of different models here. Yes, I will start two-port network. The two-port network. But initially I would like to start Z parameters. Z parameters. But how to be written these Z parameters, that is more important now. The Z parameters are written as V1 equal to Z11 into I1 plus Z12 into I2 and V2 equal to Z21 into I1 plus Z22 into I2. These two equations are said to be Z parameter equations. But how we can draw Z parameter equivalent circuits, that is very important. Once you know the Z parameter equivalent circuits, you will do problems of many, understand now. But how we can do? But V1 equal to this voltage equal to this voltage plus this voltage we know very well. The second one also V2 equal to this voltage plus this voltage. These two are voltage equations. If you got the voltage, that means input voltage V1, output voltage is nothing but V2, you know. So we need to draw Thevenin's equivalent circuit. Voltage indicates Thevenin's equivalent circuit. Current indicates Norton's equivalent circuit. The V1 and V2 both are voltage equation. Input circuit must be Thevenin's and output circuit also Thevenin's here now. But here the V1 is given, that voltage I can connect here, plus V1 is given. I would like to put this voltage equal to this voltage, Z11 is the impedance here given. That may be resistance or inductor or capacitor or any value possible. Z11 into I1 here now. Z11 into I1. I1 means current passing through this, what now? This value, what now? This element only here now. That is to be taken as a I1 I want to take. Z11 into I1 is nothing but this voltage. And the next voltage is given Z12 into I2. There I2 is not a, it is not input parameter. It is an output parameter. I2 is the output parameter. But in the input circuit, we need to arrange that I2. By using the output parameter, we need to get this voltage, Z12 into I2. So this element is dependent upon output current only. It depends upon output parameter. Depends means one dependent source I can connect. Is it a voltage source or current source? It is a voltage source, plus minus. Its value must be taken as a Z12 into I2 I can put here now. This is the input equation. That means V1 equal to Z11 into I1, Z12 into I2. Yes, when the KVL is applied, we are getting the same equation. And required one more equation. It is also Thevenin's I said here now. It is also Thevenin's means how I can do. Otherwise, a V1 supply voltage you can put, or directly you can put voltage V like this now. This is one more voltage V2. This is a V2 have taken. Otherwise, not requirement. This also you can connect such a way only now. You can put like this, no problem. V1. Otherwise, you can say directly V1 here like that. We can put no problem. Even you are putting like this, no problem. Even you connected that voltage source, not acceptable. Otherwise, plus minus. This is the V2 we got here now. This V2 equal to what? Z22 into I2. Z22 I can put here now like this. This is Z22. What current is passing through this element? I wish to take this current as I2. This current as I2 only now. And here the next parameter is Z21 into I1 you got here now. One more voltage I got, Z21 into I1. This is some other voltage. It depends upon I1. It depends upon I1 means it depends upon the input parameter here now. So I can connect one dependent source like this. Plus minus that can be taken as Z21 into I1 I can put now. So we got V2 equal to what? Z22 into I2 plus Z21 into I1. Such a way you can draw Z parameter equivalent circuits. This can be taken as a Z parameters equivalent circuit. Equivalent circuit. Z parameter equivalent circuit I can put like this now. In that way we can draw the Z parameter equivalent circuits. Understand now. And what about Y parameters? How we can take Y parameters? That can be taken like this now. Now we can start Y parameters now. I want to take Y parameters now. The Z parameters can also be called as a impedance parameters also we can call. The Y parameters can also be called as a admittance parameters here now. How we can take Y parameter equation? Y parameter equations are taken as I1 equal to current equal to voltage into admittance only. V1 into Y11, then V2 into Y12 they will put. V2 into Y12. And I2 can be taken V1 into Y12, Y21, Y21 here, plus V2 into Y22. So these are the two equations are said to be Y parameter equations. But how we can draw an equivalent circuit for the Y parameters, that is required. But you watch in Z parameters, what network you got, but now both are what? Thevenin's equivalent circuit only now. But we can check here now what network is to be plotted here now. This I1 equal to this current plus this current. I2 equal to this current plus this current. Summation of the two currents is nothing but I2 only now. But the current equations are given in Y parameter. So we can apply Norton's, we can draw equivalent circuit of, how we can draw the equivalent circuit? By using the Norton's circuit only now. Because these two are current equations. That is why by using the Norton's equivalent circuit, we need to draw Y parameter equivalent circuit. Input must be Norton's equivalent circuit. I2 is there means output also Norton's equivalent circuit. How you can draw the Norton's equivalent circuit here now? Here required the current source. This current source is to be taken as a I1. It may have the voltage V1, no problem. Even you have taken voltage V1, it's not a mistake. And here the admittance of Y11 I have taken here now. Y11. This is Y11 I want to put, because I1 equal to V1 into Y11, parallel means voltage will be same only now, plus Y11 into what, I1 only here now, Y11 into V1 we are getting. And next one is nothing but what, same V2, V1 is there now, but V2 into Y12 is given now. The second one is nothing but the voltage. That voltage is what, because in the Norton's equivalent circuit we need to have the what now, parallel combination only now. The parallel combination Y11 into V1 we are getting here now. Here V2 parameter we got, V2 is nothing but the output parameter. We need to take dependent source here now. Here to be taken as a dependent source. That's why I wish to put here one dependent source like this. This is the dependent source only now. But there it is going to flow the currents. I1 equal to what? This current plus this current, two currents in parallel combination. This can be taken as a V2 into Y12 I can put here now. V2 into Y12 I can put here now. V2 into Y12. This is the input circuit. What about output circuits? It is also Norton's equivalent circuit. I can take, this is V2 for example, the voltage between these two. But the I2 equal to this current equal to here required. This current plus this current, two currents are required now. This is dividing as a two currents. Two currents means parallel combination is a must. We cannot connect in series because two different currents only now. I can write Y22 into V2. V2 we got here. This is to be taken as a Y22. We know very well I2 equal to some current this side, that current equal to what? Voltage into admittance, yes, V2 into Y22. And one more is required here now. One more, how I can get? It is a dependent source only. It depends upon the input parameter V1. If it depends upon the input parameter V1, how I can take? I can draw dependent source like this. This is one more current because I2 equal to this current plus this current only. This can be taken as a V1 into Y21 I can put here now. V1 into Y21 I can put now. Such a way the equivalent circuit will be drawn. This is said to be Y parameters equivalent circuit. Y parameters equivalent circuit. Equivalent circuits. That way we can do. So we have drawn Z parameter equivalent circuit and also Y parameters equivalent circuits. Now I wish to plot what is H parameter equivalent circuit. The next one is H parameter equivalent circuit. H parameters I will put here now. H parameters. But how to be taken H parameter equation? That is more important. The H parameter equations are taken in this way. V1 equal to H11 into I1, H11 into I1 plus H12 into V2, H12 into V2 possible. And the second equation is nothing but I2 equal to H21 into I1 plus H22 into V2 is possible. These two equations are said to be H parameter equations only now. Because mostly in the analog circuits it is useful H parameter equations maximum only now. That means by using this you can do this small signal analysis also there, understand now. Anyhow there will be useful now. Anyhow we got V1 equal to H11 into I1, H12 into V2 and I2 equal to H21 I1 plus H22 into V2 now. But how to draw an equivalent circuit for these two equations? But you need to watch, one equation is given with V1. V1 equation is given. V1 equal to this voltage plus this voltage only now. Summation of the two voltages equal to V1 only here now. So voltage you got means input must be Thevenin's equivalent circuit only now. What about the second equation? I2 equal to some current plus some other current now. Addition of two currents will give I2 value. I2 indicates what? Norton's equivalent circuit. So we can say output must be Norton's equivalent circuit and input must be Thevenin's equivalent circuit. I can draw equivalent circuit in this way. We got here V1. Yes, we can connect V1 here now. This is V1. And because of this V1, it is going to flow current of what? I1, because it is a Thevenin's equivalent circuit. I1 only now. But here the H11, you got H11. There is the input impedance they will call. So V1 equal to I1 into H1. Yes, I1 into H11 I am getting here now. Then what about next one? H12 into V2 is nothing but some other voltage. But this voltage depends upon output parameter V2. If it depends upon any output parameter, we can draw dependent source in the network. I can draw dependent source in the network like this. This is with plus minus. This will be taken H12 into V2 I can put here now. Now whenever you are applying the KVL, V1 equal to H11 into I1 plus H12 into V2. Yes, we are getting. And what about the next circuit? What about that output circuit? I2 equal to this current plus this current. There will be required Norton's equivalent circuit. Yes, we can draw Norton's equivalent circuit. And this side you can have the current of I2. Here the voltage between these two terminals must be taken as a V2 only here now. And here I can take the sum current is divided this current plus this current, parallel combination of two required. This is nothing but H22 into V2. I have taken H22. H22 into V2 is nothing but this value, this current only now. H22 into V2 is nothing but some current is passing this side. And what about the next current? Next current depends upon input parameter I1. If it depends upon I1, I can draw one dependent source. Here required one dependent source. And this is the current source only now. This is H21 into I1 here. H21 into I1 I can put now. Yes, such a way we can draw the circuit. V1 equal to H11 into I1, H12 into V2. I2 equal to this current is nothing but V2 into H22 plus H21 into I1. Exactly we are getting. This is said to be H parameters equivalent circuit. H parameters equivalent circuit I can say. Equivalent circuit I can put. In that way we can draw the circuit. What about next one? T parameters or ABCD parameters are required. Next one, transmission parameters I will use. The next one is transmission parameters. Transmission parameter is also said T parameters. Parameters are one more name, transmission parameters are ABCD parameters you can say. ABCD parameters, any name you can put. That way, but how those equations are taken and how we need to calculate the, how we can draw the equivalent circuit also more important now. Yes, I will give now. But the ABC parameters are given as V1 equal to A into V2. A into V2 minus B into I2. B into I2. So V1 equal to AV2 minus BI2 and current I1 equal to, we can note down, I1 equal to CV2 minus DI2 we can write now. These two are said to be what? Transmission parameters. these two, V1 equal to AV2 minus BI2 and I1 equal to CV2 minus DI2 will know. Yes, like that we can put now. But anybody can draw the equivalent circuit of this. Anybody can see what way we can draw. How we need to take input and output circuits. Is it required Thevenins or Nordens at the input and output? Anybody can say? Anybody has got idea about it? How to plot an equivalent circuit for this? Any student? Yes, in this case you watch say V1 equal to this voltage equal to this voltage plus something, some other voltage will be now. The V1 is nothing but the input parameter. V1 is the input parameter. That must be Thevenin's equivalent circuits. Thevenin's only. V1 indicates Thevenin's. Input is a Thevenin's now. And second equation you want again I1 is given here. Current is given. That is also input parameter. That indicates Norton's equivalent circuit. The both parameters are input parameter only. V1 and I1 both are input parameters. In this case, we cannot draw any equivalent circuit because both are what? Input parameters. If you want to plot means what happens now? The Thevenin's and Norton's circuits will be overlapping now. That cannot be possible practically now. That's why what I wish to say, input and output are input and output parameters are same only here now. Both are input parameters. That means input circuit and output circuits with input parameters only here given now. At the time we are unable to plot the what T parameters equivalent circuit. It is not possible to draw. Understand now? So the information more important now. Next one. Next rule required. To find Z parameters from the T network. Sometimes in the problems he will give one T network. By giving the T network, he is going to ask to find out the Z parameters. How we need to calculate Z parameters from the T network is more important. Just I want to give the what now? Conditions, then after you will see the problems. To find Z parameters, to find Z parameters from T network. From T network I can say. When you are given any T network, what's the way to get Z parameters? That is more important. Nikhil Gaurav. Good evening, sir. Good evening, Nikhil. Good evening. Yes, how to find the Z parameters from the T network? Suppose you are given one T network like this. First, initially, we need to know all the conditions. Then after we can do any problem easily now. This is given as a Z1. And this side it is given as a what now? Z2, this side. This is Z2. Here Z2 is given here now. And here it is given with Z3. The voltage between these two terminals given as a V2 and voltage between these two terminals is given as a V1 plus minus. But how we can take the current directions from the given network? Because of this V1 it is going to flow current of I1. Because of this V2 it is going to flow current of I2 I can say. But you check this equation, the circuit, how is the shape? Exactly, it is in the form of the T network is given here now. From the given T network, we need to find the what now Z parameters now. What you have to do is a very simple way. Just by applying the KVL, we can get two equations. By applying the KVL directly, you are going to get two equations only now. Because we know very well, Z parameters are nothing but V1 equal to Z11 into I1 plus Z12 into what? I2 now. That I can get from the what now? This KVL. Please watch it. What about this current? This current is nothing but summation of these two currents. I can put as a what? I1 plus I2 only now. Here I can take V1 equal to, I can write Z1 into I1 plus Z2 into I1 plus I2 I can get here now. Whenever the simplification of this simplification is made, I can get I1 into Z1 plus Z2 here. Z2 into I2 I got here now. Z2 into I2. This I want to take it as equation number 1. But whenever you are comparing the Z parameters, Z1 plus Z2 is nothing but what? Z11 only now. It is nothing but Z1 because V1 equal to Z11 into I1. This becomes Z11. Z2 into I2. This Z2 can be taken as a Z12 only possible. But I am getting the first equation. It is in the form of Z parameters equations only now. And the second equation I would like to get from the what now? This loop only now. Whenever I apply the KVL here, I will get here now V2 equal to what? Here I wish to take V2 equal to Z3 into I2, Z3 into I2, Z3 into I2, this side Z2 into I1 plus I2 I can put now, I1 plus I2. If you are simplifying this equation, what I will get? V2 equal to Z2 into I1 here plus Z2 plus Z3, Z2 plus Z3 into I3 I can write here now. Yes, we got equation like this. When you are comparing with Z parameters equation, V2 equal to exactly we are getting V2 equal to, here what I can write, V2 equal to, I'm writing here now. Z2 means I can take it as a what? Z21 it becomes. Z2 plus Z3 is nothing but Z22 is mostly possible. It is in the form of Z parameters equations. So, equation 2 I have taken here. Now we can get the Z parameters by using this. How we can get the Z parameter? By using these two equations. Z parameters are taken as about Z11 here. Z11 means Z1 plus Z2, no doubt. Z1 plus Z2. And Z12 is nothing but Z2 I can write here. Z21 is nothing but Z2 here. And Z22 is nothing but Z2 plus Z3. Z2 plus Z3. Yes, by means of using this particular way, you can find the Z parameters. Whenever a T network is given in a problem, directly by using these are the formulas, directly you can get the Z parameters for it now. I think you followed this methodology. Now, how to find out the Y parameters? By using pi network, we can see now. By using the pi network, I will give now, but I want to give that also. The next one, to find Y parameters, to find Y parameters, to find Y parameters from pi network, I want to say, pi network. This is one more way. Sometimes in the problems you will see, sir, please close the bottom tab. Very good advice. Very good advice, that one. Yes, here, to find the Y parameters from the pi network is more important. But I will give the what now on pi network. Whenever a problem is given, how we can get the Y parameters from that network, you can understand from this method only now. But the pi network is given like this. Suppose you are given one of the pi network like this. This is given as a Y suffix A. y suffix a. The voltage between these two terminals, I want to take it as a V1. The current which is passing through the YA is nothing but, sorry, this is the supply current, I want to take it as I1, not through the YA. The current which is passing through this YA is nothing but V1 into YA only, no doubt. Understand now? Thank you. Okay. And next one, I can say YB is connected this side. There is YB here. This is YB. But here connected with YC. YC is connected here. YA, YB, YC are nothing but admittance values. But you may give the 2 mho or 3 mho or 1 mho or whatever it may be, understand now. And here the V2 between these two terminals, this is V2 in between these two terminals. This is a plus, it is a minus, this current is given I2. The shape of this circuit you watch, it is a pi network, it is in the form of the pi. It is in the form of the pi only now. By using this pi net, we need to find the y parameters. What way we can find? We need to use the nodal analysis. In the before case, just by applying the mesh analysis, we got z parameters. Z parameters are calculated by mesh analysis. But if you want to find the y parameters, you need to apply the nodal analysis here now. How we can apply this nodal analysis, you watch. To get the y parameters, because the y parameters equations I gave it already. I1 equal to what now? Y11 into V1 plus Y12 into V2 I gave it. In the same way, I2 also given now. Two current equations are required now. By using those two equations, we can get the what now? Y parameters here now. I say this node voltage, I can take it as a V1. Same V1 you can have here. At this node, we are going to have the voltage of V2. The same technique you can apply for any problem. Easily you can get answer. According to the nodal, this current plus, this current plus, this current equal to 0. The summation of the currents at any node becomes 0 value only now. The current direction should take away from the node. It is not a problem. Understand now? I have taken the current directions away from the V1. This current is nothing but minus I1 because the actual direction of the I1 is this side. I have taken in reverse. I wish to put as a minus I1 here. This current plus this current is nothing but V1 into YA. Voltage into admittance, you know very well. What about this current? Current through YB. V1 minus V2 I can put here. V1 minus V2 into YB I can put now. Into YB. Voltage into admittance I can write now. Summation of all these currents equal to 0 as per nodal analysis I can say. But here I want to take what is I1. I1 equal to, I can take V1 in common. This voltage I have taken common. If V1 is taken common, what I will get? YA minus YB I can get here. YA minus YB I can get. YA plus or YA minus V1 minus V2 into YB is possible here. Yes, exactly. I1 equal to, this is I1, this current is V1 into YA, and this current V1 minus V2 into what is available? YB is possible. Yes, correct now. Because I1 equal to I have taken now. I1 equal to V1 I have taken common, YA minus YB is available. What about the V2 here? V1 is plus only, sorry, this becomes a plus only now. And second equation, what I will get the next one? Minus what is available here? V2 into YB. Minus means you can put the sign directly. Minus of, this can be taken, minus of V2 into YB. V2 into YB I can get. I got the first equation, I1 equal to what? V1 is taken common. I am getting what now? YA plus YB here. Minus V2 into YB. One more equation I got. YA plus YB. Yes, this is nothing but equation number 1 I wish to put here now. This I want to put as a equation number 1. Is correct then? And what about this second equation? I wish to apply the nodal analysis at this point. this current plus this current plus this current equal to 0. Summation of these three currents equal to 0, no doubts. What current is passing this side? This is nothing but I2 reverse minus I2 I can put here now. What about this current? V2 into YC possible plus V2 into YC is possible. Voltage into admittance. What about this current? V2 minus V1. V2 minus V1 into what? V2 minus V1 into YB. I can write here now. YB. This is equal to summation of all these currents equal to 0 only now. But their I2 is required here now. I2 is nothing but minus V1 into YB I am getting here now. Minus V1 into YB I am getting here now. Plus V2 is taken common. I will get here now. YB plus YC I can get here now. YB plus YC. This is equation number 2. Now catch, just you can compare with the what now Y parameters which are given before. There what is given? I1 equal to what? I can note down here clearly. How I can say now? I1 equal to, we got Y11 into, this is Y11 into what? Y11 into V1, you know doubts. Plus V2 into minus of YB. This minus of this YB is to be taken as a minus of this YB. If it is taken, you will get what now? That becomes a Y12 is available. Minus of YB only now. And here I can say minus of what? YB is to be taken as a what? Y21 I can put here now. YB plus YC can be taken as a what? Y22 only now. Now directly you can get Y parameters by using these two equations now. How I can get Y parameters equal to Y parameters equal to Y11. What is Y11 here? Y11 is nothing but YA plus YB. YA plus YB is possible. And also Y12 is nothing but minus of YB I can put here now. Minus of YB I can put here now. And next one, the second equation, minus of Y21 is nothing but minus YB here. Minus YB I can put here now. YB plus YC is nothing but Y22. YB plus YC here. YB plus YC. Like that, Y parameters are calculated from given pi network only now. Sir, I cannot do this work, sir. No need to do. If you are in a position to remember this formula directly, you can substitute only now. Sir, I cannot muck up this formula, sir. You must do this work. I can't do both, sir. It is better to leave the question only now. Understand? Don't leave it now. 100% easily you can do by means of doing this work only now. So when the pi network is given, directly you apply nodal analysis, and easily you are going to get the what now? Solution for the problems only now. Just 2 or 3 problems I will do based upon these networks only now. You can understand clearly. Understand? Yes, I will start now. We can do the problems based upon them. It's very simple. Yes, a network is given like this now. I want to give in your hand this network. Find Z parameters. Question is given like this now. Find Z parameters. Find Z parameters for the network is given like this. 2 ohm resistor is connected here, and also 6 ohm resistor is connected here, and also connected with 1 4 ohm resistor. The voltage across these 2 terminals given as a V1 here, plus minus. The voltage across these 2 terminals, it is given as a V2, plus minus. This current is given I2 and this current is given I1. Yes, it is one of the simple problem. What way we can calculate Z parameters by using this network is more important now. But how we can do this means, please watch. When a problem is given like this, I can give the solution now. If a problem is given like this, you must apply the what now? KVL. It is a T network. When the T network is given, just KVL this side, KVL this side. This current is nothing but I1 plus I2. It flows. The current of I1 plus I2 flows this side. Finally, what equation is going to, we can form by this? V1 equal to, I can write, the drop across, this is nothing but 2I1 here. The drop across this 6 into I1 plus I2. And finally, I can get V1 equal to 8I1 plus 6I2 I got here now. This I want to take it as equation number 1. That is equation number 1. But I want to get this second equation. When I apply the KVL in this direction, I can get V2 here now. V2 equal to, I can note down 4 into I2 plus the drop across this 6 into I1 plus I2. I can get V2 equal to 6 plus 4, 10, 6I1 I can put first. 6I1 here, 6I1 plus 6 plus 4, 10I2 I can get here now. Yes, these are the values we got. Now we can compare. V1 equal to Z11 into I1, Z12 into I2, V2 equal to Z21 into I1, Z22 into I2. The same form we are getting now. So I can write Z parameter in this way. Z parameters I can write directly now. I can write Z parameters here directly. How I can write? Z parameters are how I can take Z parameters are, here I can write directly. Z11 is nothing but 8, Z12 is nothing but the 6, Z21 is nothing but the 6, Z22 is nothing but the 10. These are all Z parameters. These are all set to be Z parameters. In the mobile communications, mostly we are going to use Z parameters. Understand my point now. Anyhow, we got these are the values 8, 6, 6, 10 only now. But I want to give one more question in your hand. You please put an effort to give your valuable answer. But I want to give one more question. The next question given like this. Find Z parameters. Find Z parameters for the given network. For the given network. For the given network I want. The network is given as 2 ohm resistor here. There is one 2 ohm resistor. And also here connected with one 4 ohm resistor. And here connected with one voltage source like this. This is given as a 10V1. The voltage between these two terminals given as a V1. This is a plus, this is a minus. Here it's not connected any supply this side, any resistor. This is a V2. This is given V2. This current is given I2. The network is given like this. We have to compute the required values. Z parameters are required from the given network. You can start doing this question. How we can do this question? We know very well the current which is passing through this side must be taken I1 no doubt. That is given only now. Understand now anyhow. Apply the KVL this side. I will get the what now? One equation. Apply the KVL in this direction. You will get I2. Sorry, second equation I can get here now. But here, what net current is passing this side? I1 plus I2. No doubt, everybody knows better. Everybody knows better only now. Then how I can form equations here now? Here V1 equal to, I can note down 2 into I1 plus 4 into what? I1 plus I2. I1 plus I2 minus of 10 V1 I can get. Minus of 10 V1 I can put here now. There I can write what is the V1 here possible. V1 I have taken this side. 11 V1 equal to 2 I1 plus 4 I1 I can put as a 6 directly I can write now. This value I can write 2 I1 plus 4 I1 6 I1 I can get directly plus 4 I2 it is there. This is a 4 I2 possible. 6 I1 plus 4 I2. So finally what is V1 here? V1 is to be taken as a 6 by 11 I1 plus 4 by 11 I2 I can put now. Yes, we got the value. V1 equal to Z11 into I1. This is Z12 into I2 we got here now. That way we can get equation number 1. This is to be taken as a equation number 1. 6 by 11 I1, 4 by 11 I2 now. What about second equation? How we can form second equation? Please watch it now. But I want to apply the KVL in this direction here now. KVL, whenever I applied, I can get V2 equal to, I can note down 4 into I1 plus I2. I1 plus I2 I can get. When I go down, minus 10 V1 I can get. Minus 10 V1 I can. We know what is V1. The V1 is nothing but this value. Just I want to put here now. I want to substitute there now. V2 equal to 4 into I1 plus I2 we got here. Minus 10 into what? V1 is nothing but this 6 by 11 I1 plus 6 by 11 I1 plus 4 by 11 I2 I can get here now. 4 by 11 I2. Like that I got an equation. I got an equation like this now. But we need to simplify. Once you have simplified this, you will get the required value. Can you simplify this? Anybody can simplify? You will get V2 equal to in this way. V2 equal to, if you are simplifying this, you will get V2 equal to minus 16 by 11 you will get. I1 you will get. And you will get minus 16 by 11 I2 also. I2 also you can get. Like that equation will be forming finally. The equation will be forming such a way only now. Once you are getting such a way, you can get the Z parameters like this now. Z parameters are nothing but Z equal to 6 by 11 here, 4 by 11 I can get, minus 16 by 11 I can get here. The fourth one is minus 16 by 11. If you simplify it, it comes now. Like that, Z parameters we can get only now. Understand now. But one more question with a slight change I want to give in your hand now. How many students can do this? I will see. Understand now. I will see now. The next question. Find Z parameters for for the given network. The network is given like this. Here given with 4 ohm resistor. And one more here, the 2 ohm resistor is connected this side. This is 2 ohm. And connected with 1 ohm resistor this side. And also connected with one battery 2 volts. A battery of 2 volts here connected. And this voltage is given V1 here. Is a plus, it's a minus only. Here I can put V2. This is V2. But I want to wait for some time. Any students can give answer? Any student can give answer for this question without my help? I'll see who can do this question. Can you try this question? If anybody is getting answer for this question, very happy. You make an effort. If you tried, you can give what is Z11, what is Z12, what is Z21, what is Z22. You can message. But if this current is I1, this current is I2, I am going to get this side I1 plus I2, no doubt. In this case, generally when the T network is given, what you are going to do, you will apply the what, no, KVL. In this path, you will apply the KVL. In this path, you will apply the KVL. If so applied, what is going to happen? V1 equal to what? 4 into I1 plus 1 into I1 plus I2 plus 2 also possible. So equation is going to form with some constant also. V1 equal to, we are getting V1 equal to something plus some constant also we are getting now. Plus some constant whenever you are getting, it is not equivalent to the what, no, Z parameters equations only now. It is not equivalent to Z parameters equations only now. So if you tried, you watch what is going to happen. For your understanding purpose, I will note down here now. If you apply the what, no, KVL this side or this side, V1 equal to what I can get? I'll get V1 equal to 4I1 plus 1 into I1 plus I2 plus 2 I can get here now. Then finally V1 equal to 4 plus 1, 5I1 I can get plus I2 plus some constant I am getting. But here we are getting the what, now some constant. Whenever that constant you are getting means it is not equivalent to the what now? Z parameters equation. It is not possible. So then we can write directly does not possible to get the Z parameters from the given network only now. Understand now? Because it is not, you will not get in the form of the Z parameter equation. So we can write now, because of this constant we can write now Z parameters I can write Z parameters do not exist only now. Why they will not exist means because of this constant I am able to get the Z parameters from this network, you know. And one more question I want to give in your hand. If it is possible, you please try it. I want to give one question in the hands of the students only now. With a slight change, some extension I want to give to this question. Find impedance parameters. Impedance means Z parameters only now. Find impedance parameters. What are the ways possible to give question? I am giving find impedance parameters. But it is not asking all the parameters. Z11 is asking to find, and also is asking to find Z12. Required Z11 and also Z12, only two Z parameters. The given network is, there is a resistor 2 ohm. There is 1 ohm resistor this side. This current is taken as a I1 here. This voltage is taken as a V1 here. And here connected with one more resistance 2 ohm. And here connected with 1 ohm. And also given 2 ohm resistance this side. One more 2 ohm is connected this side. And supply voltage is given V2. The current which is passing through this side, it is given as a I2 only now. I am in need of Z parameters from this network. If you are given the 3 loops in this way, you convert into the 2 loops and you can get one T network only now. How I can do, sir? This is nothing but the this is nothing but what now? transformation what now, you know the what now, the star to delta and delta to star, you know, I think the now. Already I gave the what now videos also now. I did the videos also now. That's a what now, but this is nothing but the delta circuit. You get the what now, one T network from this now. Whenever you are converting into a T network, you are going to get one simplified form of the circuit. Then you can determine easily Z parameter size now. Further not now. You convert this portion into what now? T network only now. Then you will get easy. Star to delta, sorry, exactly. Star to star, delta form you got, you convert into T. You convert into the what now? Star to what now? Delta to star you connect now. By using that, whenever the simplification is made, you will get the T network only now. By using that T network, you can get the required parameters of Z parameters only now. Please try it. Thank you.